This video is about probability distributions and frequency tables. And our objective is to be able to make and use frequency tables and probability distributions. So what is a frequency table? Very simply, a frequency table is a data display that shows how often an item appears in a category. Think of it kind of, if you look at this box right over on the right side of the page, how it's telling us how many people like a particular type of music. Okay, this is what a frequency table looks like. It's very simply just a way to organize your information. Now, relative frequency is the ratio, which means it's going to be a fraction of the frequency to the total frequency. Now, this sounds very familiar, all right? This relative frequency, we kind of learned, but a different way. We learned it as probability. This frequency is just like success, and this total frequency is just like total. So when they ask for the relative frequency, they're really asking what's the probability based on the results of whatever you did. Maybe it's a survey, maybe it's performing an experiment, what have you. All right. So let's take a look at some examples. The first one here says, all right, the results of a survey of students' music preferences are organized in this frequency table. What is the relative frequency of the preference of rock music? Well, right there when I saw relative frequency, I'm thinking probability. I know there are 10 for rock, 7 for hip hop, 8 for country, on and on. But the first thing I got to do is figure out how many are there total. If I add all these up, I know that I have a total of 40 different results. 40 different results, okay? And I'm just going to double check real quick on the calculator to make sure that my fast arithmetic worked. And yes, I get 40. Okay. So the relative frequency for rock, therefore, would simply be the ratio of 10 over 40. And I obviously want to simplify that to 1/4. That's it. That's how you do relative frequency. So if I look over here, I'm going to kind of write this over to the side just so it all doesn't go off the screen. If I look at classical, well, that's going to be 5 out of 40, which I would simplify to 1/8. B here, if I look at hip hop, that would be 7 out of 40. Can't simplify that. And if I looked at country, I get 8 out of 40, which I could simplify to 1/5. So hopefully you're seeing this relative frequency is just an extension of what we did last lesson with probability. But now they're giving us the information a little bit differently, okay? This is still a frequency table, even though it kind of looks like it's laid on its side. A student conducts a probability experiment by tossing 3 coins one after another. Using the results below, what is the probability that exactly 2 heads will occur in the next 3 tosses? So what they're telling me is I have to look for when I got 2 heads. There's one scenario. There's another scenario. And there's another scenario for when I got 2 heads. I also need to know how many total tosses were there. And I went ahead on the calculator and added these up. And I know that there were a total of 50. So the probability of 2 heads is going to be success. Well, let's see, that would be 7 plus 6 plus 2, or 15 out of 50. I'm going to reduce that to 3 out of 10. You might have to write this as a percentage or as a decimal, and we should all be able to convert fractions to decimals to percents. If you need help with that, let me know. Another scenario, okay? They do a probability experiment. They record the results in what's called a frequency table. If I add all these up, I just did it on a calculator, and I get 100. All right? They want to know what is the probability, success over total, of getting a 4. So the probability of a 4 would be 18 out of 100, which would simplify to 9 out of 50. And again, that could be changed to a decimal or a percent. All right. Next thing I want to talk about is this idea of what's called a probability distribution. This is where they're going to describe for you an event. And from that description, I have to first organize it into a frequency table. And then secondly, show what the probability distribution is. All right. For each of the different scenarios. So for this one, I'm going to organize my information like this. I got 0 bullseyes, 1 bullseye, 2 bullseye, 3 bullseye, 4 bullseye, let me see, 5, and ooh, some people were smart enough to get 6. All right, I'm going to block this information off kind of like this. All right, I know my drawings aren't always the best, but this is how I make a frequency table. I could have also made it vertically. I just chose to do this one horizontally. Now, the next thing I want to write down is my frequencies. Frequencies are the number of times that things have occurred. So in the information there, they say we had 3 that hit none, 5 that hit 1, 7 hit 2, 7 hit 3, 11 hit 4, 10 hit 5, and 7 hit 6. All right. Now, I know that all this is going to add up to a total of 50. All right, because that was part of the information they give me. Now, what I have to do here is figure out what is the probability now. Well, this would be 3 out of 50. This would be 5 out of 50, which I'm going to simplify to 1/10. This would be 7 out of 50, 7 out of 50, 11 out of 50, 10 out of 50, which I'm going to simplify to 1/5, and 7 out of 50. This is what is called a probability distribution. I created a frequency table to display the data, and then I determine the probability of each scenario within that frequency table. So let's try that one more time. This time we'll do a math test. All right. So the information they give me is scores that were 90 to 100, scores that were 80 to 89, scores that were 70 to 79, and scores that were 60 to 69, and finally scores that were less than 60. So I'm going to organize this information here. All right. I'm going to write down what the frequency of each thing occurring was. How often did it occur? We had 10, 90 to 100. We had 12, 80 to 89. 15, 70 to 79. 8, 60 to 69. And 2, less than 60. All right. Now, this one does not tell us how many people, so I'm going to go ahead and add that up. All right. And there were 47, I believe. 10. Yep. So I got 47 for my total here. 47 scores. Now, I'm going to figure out the probability of each one of those. Well, that's simply 10 out of 47, 12 out of 47, 15 out of 47, 8 out of, whoa, what the heck did I write a 5 there for? 8 out of 47, and 2 out of 47. And again, remember, these could be written as fractions, decimals, or percentages. This is what is called a frequency distribution or probability distribution table. All right? So how can I use this frequency table? Well, they tell us in this scenario that 23 preschoolers were asked what their favorite snacks are. This time, instead of giving us a table, they're giving us a bar graph. All right? They want to know what is the probability of a preschooler getting his random chosen as popcorn. Sorry, I misread that. popcorn as their favorite snack. Remember, probability is always success over total. So our success of popcorn would be 6, and I know our total is 23 because we determined that from the directions. I didn't even need to take the time to add them all up. Okay? What about this second question here, though, that says, what's the probability, all right, that a preschooler did not, there's the key, they did not choose bananas. So probability of not bananas. Well, I know that a not can be found as by using the complement here. I know there were 8 out of 23 bananas. So that's success, right? I'm going to subtract that from 1. So this probability would end up being 15 out of 23. All right. Hopefully that helps. All right. Remember, on that last one, another way that we could have done it would have been to add up the frequency of popcorn, celery and cheese, and trail mix as another way to do that. Hope this helps. Let me know if you have any questions.